Assalamualaikum. My name is Ana Shoda binti Ahmad. Now I'm going to present my work about the new design of inner car door panel. The content for my work consists of the problem statement, objective, material selection, process selection, eco audit tool, last but not least, the conclusion. Currently, the non-renewable sources material like steel have been used to make the inner door panel. However, the steel have many disadvantages like easily corrode, it can increase the volume of the landfill, and it is a non-renewable energy, which means there will be the depletion of material resources. So, what is the material that can replace steel? And what method to identify the material that can replace the steel? And how to know that the material and the process selected is the best choice to make the inner door panel? The objectives are to perform material selection and process selection for inner door panel, which cover the four aspects in selection strategy, to relate the material properties and link with manufacturing process involved, to propose materials and process based on the design requirement. For the material selection will undergo the translation step, the screening step, the ranking step, and the documentation step. The design requirement will be translated into function, constraint, objective, and field variable. Function is what does the component do? Is what is the desirable condition for the materials to be made. The objective define the material indices, and our objective is to minimize the mass, and the mass equal to area times length times density, or equal to the width times the height, the length, and the density. To identify the material index, substitute the equation 1 into 2. The equation 2 we get from the bending stiffness as S is specified. S equal to C times E times I over L cubed. Here C is constant. That depends only on the distribution of the loads. We don't need the value of the C. The quantities of S, L, B, and C are all specified. Now we can eliminate the H in equation 3 by using equation 2, and we get this equation. Next, we will get the material index M equal to E 1 over 3 over the density, which means we maximize the stiffness and we minimize the density. Okay, now during the screening test, we want to eliminate the material that cannot do the job and cannot meet the design requirement. According to the material index, we are going to use the slope 3. And whatever the material below the slope 3 and did not meet the design requirement will be eliminated during the screening test. And the material that pass the screening test are the ABS, the hardboard, the PP polypropylene, and the aluminium. The ranking step is for the material that passed the screening test. And now we need to identify the performance for each of the properties. All of the material can last for 5 years. However, the hardboard have full marks for its density, the material cost, renewable source, and also it can be combust compared to the aluminium and the PP. The data for each of the properties can be obtained from the CES EduPack, and the score given is based on self-evaluation and also from our reading and from our research. And next, thus the hardboard, aluminium, and PP have been chosen as the final choice. Hardboard is chosen as it is resistant to impact and shock and cheaper compared to composite. Aluminium is corrosion resistant and weather resistant. PP have high chemical resistance and high durability. This is the additional stage, which is the cost performance index to maximize stiffness limited design and equal to Young modulus over density times the price. From this figure, we can identify that hardboard favors the most, means that the hardboard is the cheapest compared to the aluminium, PP, and the ABS. For the process selection, it will undergo the same step as the material selection, which is the translation. The design requirement will translate into the function, constraint, objective, and free variable. The process must meet the constraint, which means the process must be able to shape the component into 3D solid, have the estimated mass 0.1 until 0.3, have the minimum section 1 until 2 mm, the tolerance is plus minus 0.5 mm, and the most important constraint is that the process is compatible for the material chosen, which are the hardboard, aluminium, and PP. For this process selection, the objective is to minimize the cost. During screening, we will eliminate the process that is not compatible with the materials. So the metals, the thermoplastic, the composite, it is compatible with the process such as sand casting, die casting, investment casting, low pressure casting, fogging, extrusion, and so on. Next, we are going to identify whether the process that is compatible with the material can be shaped into 3D solid. So the highlighted process compatible with the highlighted material. Now we will identify either the highlighted process which can form the product into 3D solid shape. Now, does the process able to satisfy the mass constraint? You can see now that the sand casting, the resin transfer molding, and the layout methods did not pass the mass constraint as it did not touch the green line. The green line is actually, according to the mass constraint, the range for the green line or the value for the green line is actually according to the mass constraint. Next, so the process that meet or satisfy the mass constraint is the die casting, investment casting, the fogging, the powder method, the machining, okay, all the highlighted process. Now, can this process satisfy the section thickness? So we can see that die casting, powder method, lateral machining, conventional machining, injection molding, and okay, that's all that satisfy the process that satisfy the section thickness constraint will be evaluated on the tolerance constraint. We can see that the die casting, powder methods, and injection molding that satisfy the tolerance constraint. As you can see, die casting, powder method, injection molding having roughness lower than 10 micrometer. And from the screening test, we can identify the die casting and powder method as the selected process. For process selection, you're going to do the ranking step by using relative cost per component. We can see from the graph that powder method process is more cheaper than die casting. Even the number of components produced more than 10,000, the powder method still cheaper than the die casting. Thus, die casting uses higher pressure and generally gives the highest quality casting, but tend to give flow marks on the component. But for powder method, it have a very large family range, such as die pressing and sintering, powder extrusion, hot pressing, spray deposition, powder injection molding, and hot isostatic pressing. An eco audit is a fast initial assessment which recognizes and compares the phase of life like material, manufacture phase, transport phase, use phase, and disposal phase that carries the utmost demand for energy or produce the greatest burden of CO2. The input assessment of each of the material having mass of 1.6 kg, transported using a 14-ton truck with 50 km for transportation of the product from manufacturing site to point of sale, and the use life for 10 years. And the product is part of the vehicle that will be used for 250 days per year and 10 km per day. Only the type of the material is different in the input assessment of Eco Audit 2. An overall assessment of the Eco Audit tool shows that the material phase of life consumes far more energy than all the other phases, and the largest contribution to energy consumption and carbon dioxide generation derived from the production of the aluminium used to make the inner car door panel compared to the hardboard and the polypropylene. Conclusion: the hardboard is chosen to be the best material due to its high stiffness, but also light and cheap, and the powder method has been chosen as a process to make the car inner door panel due to it is more economical and compatible with the hardboard. Thank you.